Our second speaker is Roy Vasher. I ran into Roy several years ago when we wrote a book on Toyota supply chain management. And if you're ever going to write a book with Roy, know that your book will be written on time, because he'll take the time, divide it into a number of pages per week, and get the job done. Well, since retiring from Toyota, Roy has worked on several roles for us here at Purdue, both in our executive program, and he's also been helping us with respect to projects on next generation education as part of WIN. Roy's been a speaker on various topics, including robots for warehousing, a Silicon Valley startup, investing in Warren Buffett's investments, etc. So he's going to tell us how to make as much money as Warren Buffett. Yes, yes.
I got a wireless mic. Can you hear me okay? I apologize. I got a little sinus here from the allergies, so I'm a little fogged up, but hopefully you can hear me. So let me talk a little bit about next generation manufacturing. And the way I compiled this is combining lean with smart technology. So one of the things I want to emphasize that, we've talked a lot about technology, IoT, and sensors and that, but before you run out and start buying things or investing in things, you need to make sure operation is running smooth and your processes are streamlined. So that's where lean comes in. Thinking back to, I think it was in the early 80s, General Motors invested a lot in robotics back then, I think in the body shops and other technology, and they couldn't imagine why it wasn't solving their problems. And I think after a few years and billions of dollars of investment, they decided to pull the robots back out and go back to figuring out how to make cars more effectively and streamline their assembly lines. So that's an example where rushing to smart technology, in that case not smart technology, but technology wasn't the solution to their business problem. So that's one of the key messages I'd like to get you to take away three things today. One is the importance of having a solid foundation with lean processes before you can take the next step into smart technology. It may be okay, as we talked this morning, to pilot test some technology, but before you try to roll it out plant-wide, you need to make sure your processes are streamlined. The other thing is that it takes leadership to build a next generation manufacturing, because leadership, as I think somebody talked this morning, is important when you're making, like Frito-Lay, you talked about the leadership to educate people, make people aware of the change that's coming. So leadership is an important role of next generation manufacturing. And then, of course, you need to educate yourself on what is the smart technology that is available and what is the business case that will make it improve your cost or reduce your costs and improve your productivity. What is lean? I think everybody pretty much is kind of a generic term today, so it's almost overused, but as most of you know, it was based on the Toyota production system. Toyota invested a lot of time back in the 60s to understand how to eliminate waste in their processes. That's the foundation of lean is eliminate waste, and I'll talk a little bit about types of waste in a minute, but the whole thing is the value stream of the business flow all the way from your suppliers to the plant to your consumers is a value stream, and you need to understand the value-added and non-value-added aspects of that and systematically eliminate that waste. And it's a never-ending activity. You really are never done, so whenever you reach a certain plateau, you need to set another goal to go to the next level. And now with the introduction of technology, you can improve that even more. But Toyota learned about these principles from Dr. Edwards Deming back in the 1960s. Does anyone here know about Edward Deming's principles? There's a few of you. Has anyone ever met Dr. Edward Deming? No? Well, I was fortunate when I worked at Ford back in the 1980s. I actually attended a 5-day seminar taught by Edward Deming. So I didn't realize at the time, I probably should have paid more attention, but looking back at history, I probably would have learned a lot more if I realized how important he was. But anyway, I had the advantage of listening to him personally. And these are the 14 points. And I won't read each one of these, but they're up there. And obviously, you can Google Deming, and you can see on the internet. There's many books written about his principles. But you can see where Toyota took these principles, and they became the foundation for the Toyota production system, which is the foundation now for Lean. So the whole idea is, there's a lot on philosophy of how to continuous improvement, improve your product and your service, which is always important. Ceased, inspection. Don't inspect at the end of the line. Build in inspection in the line. Pokey Oaks and other technology or procedures. It's a lot about people. Institute training on the job. And if you look over on the other side, it's basically empowering the workforce. And that gets what we're talking about leadership here, and to always make sure that everybody's working for what do you call a true north goal of the company. You want everybody to be focused on the same objectives, no matter what department. And that's one of the things that talks about number 9, break down barriers between staffs and departments. Since I worked several years at Ford and Toyota, people ask me, what is the big difference between the two companies? And that's one of the big differences, that at Ford, I felt, of course, I didn't know it at the time, I was in a silo. I was in one department, and I really didn't understand what anyone else in the company did because I wasn't, told to go talk to someone else and try to work across the department lines to solve problems. With Toyota, it's just the opposite. You always are communicating horizontally across the organization. You're looking at processes and improvements in a wider spectrum. So it's one of the big key differences from Toyota and Ford. Now, one of the things when I joined Toyota is I went to a 2-week training session in Japan, and it kind of get me indoctrinated on the Toyota culture and the principles of Toyota. And one of the slides, actually wasn't a slide at the time, the instructor went to the blackboard or whiteboard, and he wrote these 2 formulas on the board. And his comment and question was, what's the difference? And algebraically, obviously, the same equation. But the difference is that traditional companies back then viewed price is set by adding cost plus profit. So basically, the old theory is you add up all your costs, and then you decide how much profit you want to make, and that determines the price. So that type of thinking, obviously, from a Toyota's point of view, it was backwards, because their view is that the profit is the result of price minus cost. So the only way you can improve your profit is to reduce cost, because price is set by the market, the competitors, and so on. You can't just arbitrarily increase price because of competition. So their mindset, and they train everybody from the get-go in the organization, is that profit is a result of price minus cost. So reducing cost, and that's where the lean thinking comes in, is constantly reduce cost to improve profit. So these are the 7 types of waste that I'm sure most of you that have read about. But just to think about, there's 2 types, 2 categories of waste. One is the pure waste, like defects, things that don't add anything to the process. But things like transportation is a waste. It's truly not adding value, but it's something you have to live with, because suppliers and OEMs are a distance apart. Even within a plant, you have forklifts or some other vehicle to move parts around. So transportation is a waste that you can't eliminate completely, but you can avoid or reduce. For example, Amazon obviously currently are delivering boxes by courier, but they're experimenting with drones. So that would certainly shorten the lead time to deliver if they can get that technology approved. So these are the primary, and there's the eighth waste that is taught in Lean is the fact that you're underutilizing your workers' intellect. So that's where it's important to think about everybody in the organization is able to contribute using their brain power to come up with suggestions, ideas on improvement. And again, that's the leadership thinking. Now, there's Lean terminology, and I'm not going to go through all the Lean concepts here today, but obviously there's a lot of them: visual control, just-in-time, Poka-yoke, Kaizen events, and so on. Some of these are tools, some of these are practices, but two I'll touch on that are very important when you talk about Lean process is value stream mapping and problem solving. But before I get into that, I want to focus a little bit about leadership and the difference between the traditional leadership and Lean leadership. So traditional leadership is more of a top-down, is leaders are telling people what they need to do. And so basically leaders are controlling the processes. The leadership states beliefs and principles and techniques that creates a culture where the human resource system is expected to ensure that the workers perform their duties. So basically, do as you're told, in the old style management. But now in the Lean organization or the Toyota type is that the leaders are the servants of the workers. So the leaders shows the commitment based on beliefs and principles to guide the team in developing techniques that form and maintain a culture that sustains the human resource system that delivers competent team members who are continuously improving the business. So it's a way of thinking. So, it's a really, powerful commitment when if you ever show your team members this kind of a understanding of what your role is as a leader, that you're serving them, empowering them to continuously improve the business. Oops. So problem solving, at Toyota, we always practice like an 8-step problem solving. Some companies have 5 steps and so on. But the big thing at Toyota in Lean is grasp the current situation. So the whole idea, and this is where value stream mapping comes up if you're looking at a process flow. If you're looking at a machine down, that's a different story. But the idea, you always want to go see the operation that you're investigating. If it's a machine down, you want to go observe it, understand it firsthand. If it's a process, you want to flow chart it out and understand the weak points. You also want to gather data, quality data, production rates, and so on. Then you want to use a scientific analysis principle to analyze data. Use fact-based analysis, not assumptions or other subjective evaluations. Then root cause analysis, drill down to find out the reason why it's happening. Then you set a target for improvement. Sometimes it's a small step, but you want to get the motion of continuous improvement going. So you don't necessarily set too high a goal for improvement. You set something you can achieve in 3 to 6 months or a short period of time. Then you identify the countermeasures for each of the root causes, and then you develop an implementation plan that makes sure you know who's going to do it, when you're going to do it, and where. But then you also need to measure something. How do you measure success? Because sometimes you implement a change and it actually makes the problem worse. So you want to make sure you're monitoring a KPI or some metrics that you can show whether or not the process improvement is making an improvement or making it worse. And of course, you don't want, even though you're encouraging all your workers to come up with changes and ideas and empower them, you want some kind of a review process before they implement, because you don't want people willy-nilly going out and making changes without some consensus from the team or management on whether or not it makes sense to make that change. So value stream mapping is basically, it's almost like a map or flow chart of your processes, all the different processes. And one of the classes I teach here is value stream mapping. When you start out, you don't start with the whole company or your whole supply chain. You start with one little project or little work cell, and you map that. Or it could be in an office where you use like a swim lane flow to identify workflow. So the whole idea is you want to document clearly, visually, the process. And here's just an example one of my students put together. It's usually organized where information flows at the top. So you want to know what triggers a process, or what triggers a start of production or start of a process, and then you go through each step and identify the little grid at the bottom as value-added steps and non-value-added steps. So now I want to talk a little bit about smart technology. So again, you got a foundation. Now you need to understand what are the technologies available, and you've heard terms like big data and data analytics, AI, and so on. So the idea, as we talked this morning, all this data is got to be stored somewhere, and most of it is going in the cloud. If it's not in the cloud, it could be in your corporate servers, but it's got to have huge amounts of storage because you're collecting raw data. You're not summarizing it and putting it into databases. We just heard you're collecting raw data. So then you need data analytics or some algorithm in AI to understand this data and make decisions. And that AI drives the technology. You've got sensors pulling data up, then you've got AI driving robots or other technologies. So I'm going to talk just about robots today because I'm involved with the company, not to mention Silicon Valley startup company called HDS. It's actually a company that's developing automated warehouses for distribution. They talked to me 3 years ago about getting involved with Toyota, so I was able to make arrangements for Toyota to invest in this technology for future use in their assembly plants. So the whole idea is that within the walls of the factory or warehouse, you've got materials. It could be food, it could be parts coming in from a receiving dock. It gets converted over into some kind of a standardized tray or rack that has an RFI tag, and that then can be moved by mobile robots either to a storage location or to a picking station for robots to pick parts and put in kits to go to an assembly line or pick a box of groceries to go to your doorstep. And there's all different types of shapes of the different racks in the trays. So the idea is that the older systems were much more large conveyors and hard, not wired, but built-in set of conveyors moving goods around. With the idea of mobile robots, it could be hundreds of little mobile robots roaming around the factory floor or warehouse, much more agile, much more flexible. So you don't have to have rigid positions for storage racks and so on. You can move them around and reprogram the robots. And with AI, you don't really reprogram it. They reprogram themselves. So another example of the new racking concept, you can have tall racks with narrow aisles to store totes of products away, and the robots can go find them when they're needed to be shipped out the door or shipped to the assembly line. And here's an example of a mobile robot. And like I said, this is just one, but you can imagine hundreds of these roaming around. Obviously, they're smart enough not to run into people or into walls, and they learn as they go. They can remember, obviously, where materials were stored in the racking system, and based on the storage location, when they get an order for something, they can go pick it and move it back to a workstation. And then the old picking concept, and I think Amazon still uses this, even though the robots are moving the tray, the carts to a picking location, people are picking the products off of a cart. The new picking concept is automated pickers that pick different shapes of parts or products and put them in a kit. And here's an example of new style picking stations. So again, you can have hundreds of these picking stations, so the system will know what part needs to go to what type of picking station to be picked, or what type of a product, so that you have different types of grippers that can pick the product. And in this case, it shows an example where there's a carton that is being packed up to be shipped to someone's doorstep. So this could be somebody ordered groceries for dinner, and the robot automated goes, packs up a box to be delivered. And this is another example of just showing some of the different grippers and different types of products that can be programmed to move. So the whole idea is that the product, whether it's a part, once the system visually sees that, takes the facial recognition of that part, understands the weight, the metrics, then the robot will automatically program itself to pick it correctly every time. So the whole thing that makes this type of solution work is a comprehensive software solution, because you've got to have something that is understanding where information is, where product is, and is controlling it, so that with the new RoboFS type software solution, you have a single software solution that is basically replacing your warehouse control and management systems, and it can be integrated to your ERP or business system to understand how much inventory you have in a warehouse, a plant, and so on. So it's a quite powerful solution. This is still not implemented yet. It's still in the final design stage, but will be implemented soon. Okay, that concludes the discussion. I think we're going to have questions in a few minutes.